open your textbook and see that oxidation reactions. Oxidation reactions, all of you. Now, this part, oxidation reactions, right? Oxidation reactions. So first of all, we see normal oxidations, then we'll take important one also. First of all, a normal oxidation when you do with what? Potassium permanganate. When you do a normal oxidation with potassium permanganate here, KMnO4, okay? Nitric acid generally will take, most of the case will take potassium permanganate or potassium dichromate. I'm writing here, when you take KMnO4, right? Or when you take what? K2Cr2O7. Whatever I'm writing is visible for you, or HNO3. Is it visible for you, whatever I'm writing?
Yes, sir.
Yes, sir.
Now these are the oxidizing agents. Okay, these are the strong oxidizing agents. Better, they are strong oxidizing agents. Very, very strong. They are strong oxidizing agents. They are strong oxidizing agents. Now, if you use these strong oxidizing agents, aldehydes are directly converting into carboxylic acids. They are directly converting into carboxylic acids. Right? Now, even if you take what happened, ketones. Ketones, what if, for example, aldehyde writing is very simple for us. For example, if I write something like this, CH3, CHO. Now, what is the product we get if I take what? KMnO4. Tell me better, what is the product we are going to get here? Which product we get here? Yes, here R is CH3, CHO converting into COOH. Now tell me, what is the product we are going to get here? It is called what? Nobody knows.
Ethanoic.
Acetic acid or ethanoic acid, right? For writing the aldehydes is very simple for us. But what about the ketones? If you take ketone, how to get the products here? That means we can break the bond here, or we can break the bond here. So we get 4 types of products actually. When you take what oxidation with ketones, we get 4 types of products. How? Let me see these products actually. For example, I'm doing like R, CH2, right? C double bond O, CH2R. This is the given example only I'm taking. Now, if I want to break here, okay, now this part will convert into carboxylic acid, and this part also will convert into carboxylic acid. Let me see this one, R, CH2, this part, C double bond O will convert into carboxylic group, COOH like this. And this part also will convert into carboxylic group, R, CH2 will convert into COOH. So we get 2 types of carboxylic acids. So this part will convert into carboxylic acid at here, and this part also will convert into carboxylic acid at here actually. Otherwise, if we get cleavage at here, this side if we get R, CH2, again C double bond O, CH2, R. Now here what happened? Like this. Here what happened here? This will convert into RCOH. RCOH. Isn't it? And this part will be what? RCH2COH. Now they looks what happens same only. This product and this product same only. But if I make any R dash here, if I make any different group, what happen? Definitely it will be R dash COH, and definitely it will be R dash CH2COH like this. So in that case, what happened? They will be different actually. If I take a R dash, what happened? One is what? R dash COH, other is RCH2COH, Other is RCOOH, other is what R dash CH2CO. That means how many products we are getting? 4 products we are going to get. Isn't it? You got 4 products. So by cleavaging at here C1, C2 or C2, C3 cleavage, you will get 4 type of products actually. We'll take one example here. We'll take one example to explain this one. All of you please note down this one. CH3, CH2, C double bond O, CH3. Right? Now first of all I will cut this part actually. Right? This part I am cutting here. What I am getting here? CH3, COOH, this part. Right? Next, if I cut this one, that is also what? Same. CH3, COOH. Right? Otherwise, if I cut like this, CH3, CH2, C double bond O, C. If I cut like this, what happens? This part will convert into carboxylic acid. CH3, CH2, COH. And here only one carbon is there, that will convert into carboxylic acid CHCOH. One carbon is there, that is also converted into carboxylic acid. Okay, this is about this oxidation of aldehydes and ketones. That means aldehydes are giving only one product, whereas ketones are giving several products actually. Understood? Everyone?
Yes, sir.
Mild oxidizing agents. Previous one are strong one. Now let me see mild oxidizing agents which can distinguish aldehydes and ketones. But now we have to distinguish aldehydes and ketones. So by using the Tollen's test and the Fehling test, we can easily distinguish what? Aldehydes and ketones. Now, Tollen test will give positive to what? Aldehydes. So Tollen test is given by whom actually? Aldehydes will give Tollen's test. Ketones do not give the Tollen test. Now why? What is the reason here? Simple. Aldehydes and ketones, which is more reactive better? Which one is more reactive?
Aldehyde.
Aldehydes.
Aldehydes more reactive, right? When you compare with ketones. Now already they are mild oxidizing, that means weak oxidizing agents. Now weak cannot react with what? Less reactive. Weak can react with what? More reactive. Now which one is more reactive here? Aldehydes. Therefore aldehydes being as more reactive, they can react with even mild oxidizing agents also. But ketones are less reactive, they cannot react with mild oxidizing agents. So what I mean to say is here, Tollen's test is given by whom? Aldehydes. So by using Tollen's test, we can distinguish aldehydes and ketones. How? Now first of all, what is Tollen's reagent? What is Tollen's reagent? Ammonical silver nitrate solution, generally called ammonical silver nitrate solution, is called what? Tollen's reagent. Now what is this ammonical silver nitrate solution? Ammonia plus what happened? AgNO3. AgNO3. Isn't it? In presence of some base also we are using actually. In presence of some base. Ammonia silver nitrate. Ammonical silver nitrate solution is very important. You just round up this one. I mean, underline this one, Tollen's reagent. In your textbook, ammonical silver nitrate solution is called what? Tollen's reagent, isn't it? Now, how to identify whether the reaction is completed, whether positive test is happened or not? How you see that one? When you get a silver mirror here, you are going to get a silver mirror. The silver mirror, if you get, that indicates it is aldehyde. Okay, the production of silver mirror indicates it is aldehyde. Now, in this case, what happens here? Aldehydes again will convert into carboxylic acids only. Same reaction, but you are getting what here? Silver mirror here. This is a silver mirror you are going to get. This is a silver mirror, right? Now, how to write the reaction here? Aldehyde. Write down aldehyde. Take silver and ammonia taken 2 times and take base here. This will convert into CO minus and Ag will convert into precipitation. Remaining will be water and ammonia. Okay, this is a reaction actually. How to write this reaction? Like very simple. Aldehydes, RCHO, will convert into what? Carboxylate ions, RCOO minus. Okay. Next, the silver. How you get from the silver diamine silver, from diamine silver, you are going to get actually what? 2 moles of AgA. Remaining water and ammonia will be byproducts. And this indicates actually what? The presence of aldehyde. And similarly, we can do Fehling test also. Fehling test also useful for the distinguish of aldehydes and ketone, in which again aldehydes will give positive test. Now here Fehling solutions will be 2 types here. One is Fehling's A, other is what Fehling's B. So both collectively called as Fehling solution. Fehling solution A, Fehling solution B. Now Fehling solution A carries what actually? Aqueous copper sulfate. It contains aqueous copper sulfate like this. Aqueous copper sulfate. Aqueous copper sulfate it contains. Plus Fehling B solution contains what? Sodium potassium tartarate of alkaline. Alkaline sodium potassium tartarate, also called what? Rochelle salt. Rochelle salt also called as Fehling's B solution. Okay, Fehling B solution. So in examination, nobody asks write molecular formula of this Rochelle salt. Nobody asks molecular formula. Simply you remember the name: sodium potassium tartarate. Alkaline, because you are adding some base into this one. Alkaline sodium potassium tartarate is called what? Fehling solution called B. Now collectively Fehling solution A, aqueous copper sulfate, plus what happened? Fehling solution B, alkaline sodium potassium tartarate is called what? Fehling solution. Now if you add these solutions in equal amount, okay, to what? Aldehyde, then what happened? Isn't it? You are going to get reddish brown color. This is what giving a reddish brown PPT you are getting because of the copper actually. Cu2 plus O, isn't it? Cu2O actually. So in this case also same thing is happening. Aldehydes are converting into carboxylic acid. Here it is same thing only. But where it is changing actually? This part. This copper plus 2 is converting into copper plus 1 beta. In this case actually, what happening actually in this case, if you observe here, what happening here, if you observe in this case, that's copper plus 2. Copper plus 2, where you get copper plus 2 from this one. In this case, copper is which condition beta? Plus 2. So this copper plus 2 will convert into copper plus 1. Copper plus 1. So, but I'm writing copper plus 1 in the form of like this, Cu2O like this. Cu2O is nothing but cuprous oxide. Now cupric is converting into, cupric means what? Plus 2 is converting into cuprous here. Cuprous here. Plus 1. Cuprous means what happened? Plus 1. Ic means what? Higher oxidation state. As means what actually? Lower oxidation state. So these are the 2 tests useful for what actually? Identification of what? Or distinguish of what? Aldehydes and ketones actually, right? Now all of you please in your notebook write down Tollen's test and Fehling test, and both are given by the aldehyde but not the ketone. Okay, what is the reagent for Tollen? Yes, better.
Sir, Fehling's test will not give aromatic compounds will not respond Fehling's test, no?
Aromatic aldehydes are there that do not understand, they don't give the test. That is not there in the syllabus, so leave it this one. Okay, aromatic aldehydes, okay, that does not give that one. For example, I will take that one, something like this. Benzaldehyde, even though it is aldehyde, okay, it does not give the Tollen's test. Or even what happened? Remaining test, isn't it? What is the reason? Because of the pi bonds here. Because of the pi bonds, what happened? They don't undergo reaction here. So here, benzaldehyde do not give the Tollen's test. You write a note there here, wrote a note here, benzaldehyde being as aromatic aldehyde do not give the Tollen's test, even though it is having what? Aldehyde. That means which will give aliphatic aldehyde like CH3CHO, isn't it? Like that, aliphatic, which are not having the aromatic. This one will give. If you observe what happened, this will be give because it is not aromatic compound. But if I put any ring in this case, they don't give actually. Okay, right? So practice this Tollen's and Fehling solution, right? Next, if go for what I here, methyl keto groups here, halo form test. So just I will take this one on the here only. Better to take here. Now I will take iodoform test here. Iodoform test is very important beta. Very important and very simple here. Iodoform test. Also called halo form test also. Taken as what? Halo form test also. Now which will give halo form test? Iodoform test is given by which group? Whichever is having what? Methyl keto group like this. They are giving what? Iodoform test. For example, I am writing here CS3 C double bond O H. All of you please note down this one because it is not there in the textbook. Please note down here. CS3 C double bond O CS3. This will give. Next what happens? CS3 C double bond O CS2 CS3. This will give. Next what happens? CS3 C double bond O phenyl group I am taking here. pH. Name of this one is called acetophenone. Acetophenone. Right? All they are having what group? You see, methyl keto group is there. Yes, methyl keto group is there. So methyl keto group is given these types. Methyl keto groups. Here also what happened? Methyl keto groups. Correct? Now let me see this one. This will give propanol is giving iodoform test. Is it giving iodoform test propanol?
Yes, sir.
This part, this propanol is giving iodoform test. This will come in MCQ questions. Application part you will get this one. Does it give iodoform test or not?
This will not give, sir.
Definitely it will not give. Because it does not have CS3 C double bond O group. Methyl keto group is not there. You need what happened? Methyl keto group here. Methyl keto group means this part. This part is there? No. So it does not give here. Isn't it? For example, if I take what happened CS3, we just C double bond OPH. Does it give iodoform test?
No, sir.
No. Now
No,
this,
sir.
what is the name of this one beta?
No, sir.
What is the name of this one beta?
Benzophenone.
Benzophenone. Now question is that how do you distinguish benzophenone and acetophenone? How do you distinguish benzophenone and acetophenone? Which test we use?
Haloform test.
Iodoform test or haloform. Generally iodoform test. Haloform is nothing but halogens. Iodoform is in that example actually. Okay. So this will give iodoform test. This is giving what? Iodoform test. Yes. This is not giving iodoform test. So by using iodoform test, we can distinguish what happened acetophenone, benzophenone. This question was asked a number of times in examination. How do you distinguish this? Very important. Okay. Understood whatever. First two things are very important. First thing is that you should understand what is methyl keto group. What is the meaning of methyl keto group? Then go for this one. CS3 C double bond O group. And here you should not have OH group. So you may ask, sir, CS3 C double bond O OH. Here also you are having no CS3 C double bond O group is there. No. Does it give? No. It must be what actually? Carbonyl compound. Remember this point. Methyl keto I said here. Methyl keto I said that it must be carbonyl compound. Maybe aldehyde, maybe ketone. So what I am saying, iodoform test is given by whom? Carbonyl compounds. Understood here? carbonyl compounds which are having CH3C double bond O groups compulsory, methyl keto groups. So again, I'm repeating, iodoform test is given by methyl keto groups only by the carbonyl compounds. If you observe, this one is also having methyl keto group, but it's a carboxylic acid, does not give. For example, if I write like this, does it give CH3C double bond O, OR? Ester it is. Does it give methyl keto test, iodoform test, ester? This part will give or not?
No, sir.
No,
No,
it
sir.
never gives here. So what I mean to say here, what happened? Only carbonyl compounds are having with methyl keto. Even though it is carbonyl compound, they are not giving because they are having no absence of what actually methyl keto. So take these examples, all of you. Write down your notebook what happened. These examples here: acetaldehyde, acetone, butanone, acetophenone, benzophenone, propanol. Isn't it? Take example, these which are giving, which are not. You write any number of examples in your notebook. N number of examples you can write. Now here, one exception is there here. What is that exception when you see here? What that exception you are having in this one? Which exception you are having in this one? Now, exception, if you observe what happened, ethyl alcohol, when you go for what happened, ethyl alcohol, CH3, CH2OH. It is ethyl alcohol or ethanol. Ethanol or ethyl alcohol. Now, this is also giving what? Iodoform test. Even though it is not carbonyl compound, is giving. Why? Because what is iodoform reagent? I2 in presence of base. You take any base. Base is nothing but what? OH minus or KOH, whatever you can take. Now in this case, it will convert into what? Acetaldehyde, CH3C double bond OH. Now definitely this will give no iodoform test. So when you take ethanol, this ethanol is converting into, with iodoform reagent, it is converting into what here? Acetaldehyde. Now acetaldehyde generally will give no. So what is the exception we can take? One exception. Ethanol is giving iodoform test. Second exception, if you write here what happened, CH3 CHOH, and you take any group here R, definitely it will give. Why? Because again, if you take iodoform reagent here, a base, if you take what happened here, this is converting into what? CH3 C double bond to R. So here also what happened, methyl keto group is you got this one, so it is given. That means with iodoform reagent, these things are converting into what? Methyl keto groups, therefore they are giving. I will write one example for this one. Isopropyl alcohol. I am writing what? Isopropyl alcohol. This is called what? Isopropyl alcohol. This is called what? Isopropyl alcohol. I am writing here isopropyl alcohol. Now, if it react with iodoform reagent, I2 in presence of base, KOH. Now, this will convert into what actually? CH3, C double bond O, CS. Converting into, isn't it? Methyl keto group. So, isopropyl alcohol. Whatever it may be, R, if you have anything here, R. I have taken R plus CS3. In the place of R, I have taken C. You can take CS to CS3 also, you can take. So, two exceptions I have taken, isn't it? One is ethanol, other is what happened? Isopropyl alcohol. These also will give iodoform test. Understood here? Any doubts you are having? Any doubts you are having, beta?
No, sir.
Right. You see here? We're using CS3C. If you read like this, what happened is difficult for you. If you read like this, it is very difficult for you. But if you write like this, it will be simple for you. Write down like this, it will be simple for you. That is the reason, write in your notebook these two things. It will be easy for you. Remembering also very simple when you write like this. Now let me see what happened. At least one methyl group linked to the carbon. What is the methyl keto means? What is the meaning of methyl keto? The meaning of methyl keto means what? Having a methyl group is linked to what? A C double bond O group here. At least a C double bond O is linking with what? A methyl group. Right? Now let me see the reaction now. How to make a reaction here. Now we'll make a reaction here. We'll write a reaction here. So here actually iodoform reaction I'm taking here. Because X means you can take chlorine or bromine or iodine. Okay. I'm placing X is equal to what here? You can take like chlorine, bromine. If it is chlorine, chloroform test. If it is bromine, bromoform test. If it is iodine, iodoform. If it is X, haloform test. So if I take what happened, iodine in presence of base NaOH. Now what happens here? Now both will react to give what? NaOI. NaOI plus HX will be, HI will be formed. Now this NaOI I am taking. For example, if I take X2, I am taking X2 in presence of NaOH. Or KOH also you can take. You can take even what? KOH also. Now what we get here? NaOX plus what happened? HX. Now you can take directly this sodium hypohalite, or you can take this part also. Both can taken as a reagent because this will convert into like this. Okay, this is called what? Sodium hypohalite, isn't it? This part, sodium hypohalite. Okay, so what we can write here? Halogen in presence of base or sodium hypohalate. Both are called, isn't it? Iodoform or something, haloform reagents here. Now either you can take what? Like this also you can X2 in presence of NaOH or KOH you can take. Or NaOX also you can take. Why? Because if they ask in conversions, in that case you should need identify this. What is the meaning of NaOX? If you see NaOX, it will be what type of reagent? Haloform reaction it is. Okay. Now how to make the product here? How to identify the product here? How to write the product here? It is also very, very simple. I'm explaining with a simple example like this. We'll take a simple example better, CH3. First of all, I will write R, then we'll take CH3, CH2. Two examples we'll see. R, C double bond O, CH3, reacting with what? Here, NaOX. NaOX. Now, how to make the product here? Now, remember in this case, you break the bond here. You break the bond here. Okay, now what is the reagent we are taking? X2 in presence of base. Correct? Now, what I am doing here, you break this bond, convert this one into what? RC double bond O, isn't it? Now, what you are taking reagent beta amper? ONA. Correct or not? ONA. Now, put here ONA. Completed? Put here ONA. Remaining is what actually X is there? No. Now, all hydrogens replace with halogen like this. All hydrogens replace with halogen. CX3. And put one hydrogen here. In this way, we can easily, this is called iodoform. The name of this one is called iodoform. Okay. I am taking one example here. CH3, CH2, C double bond O. Is it visible for you? Shall I write on PPT?
Visible, sir.
Visible,
right. CH3. Right? Now, this one, I'm treating with what? NaOI. I'm treating with what? NaOI. Now, first of all, what I have to, where I have to break here? I have to break where? Here. At the CS3. Wherever CS3 is there, there I have to put, I have to break here. Here CS3 is there, no, here I have to break here. Understood here? CS3 I have to break here. Now here what I have to add here? ONA I have to add. ONA. Where? Here. What we are going to get here? CH3, CH2, okay, C double bond O, ONA. This one you are going to get. The name of this one is sodium. How many carbons are there? 3 carbons. Sodium propanoate. It is called what? Sodium propanoate. Sodium propanoate. Because it is ester. Right? Next. This CH3 will convert into what here? CH. Okay? 3 hydrogens are there here. I3. This is called what? CHI3 is called what? CHI3. Isn't it? This is called what actually? Iodoform. Therefore, it is called iodoform test. Understood? Very simple or not? But if you practice in this,
Yes.
you can't get anything. You definitely will forget everything. If you practice directly like this, what happened? Definitely will going to forget this. You observe this one also, and the entire this part where you have to break beta. Here you need to break it. Now ONA, where you have to keep beta? ONA. Here you have to keep it. Here you have to keep. Now what you have got? You said this one. Same thing. ONA you got. See, in the place of this one you got ONA. Now this part CS3 is now chlorine. You are there. You are taking chlorine. No, take CSCl. Right. Completed. Looks what happened. Difficult. Looks what happened. Very lengthy. But what is happening here? Very, very simple. You are breaking the bond at here. Okay. Now putting ONA at the C double. You add this ONA to C double bond O part. Add ONA to the C double bond O part and convert CS3 into what? CSCl. Because you are having a chlorine, convert that one to CSCl. Everything is complete. A hard reaction you can convert into simple one like this. Practice in this way only. Write down everything. Same like this. Okay, don't read the textbook directly like this. If you read directly what happened, very difficult to remember. Any doubts you're having?
No, sir.
Now, if you observe what happened, one exercise is given here. You just try to solve this exercise, 12.4. I don't think this type of lengthy you will get in examination, but try this one because everything is given. You try this one problem 12.4. Okay, right. Now we'll see what some small topic alpha hydrogens. Isn't what are alpha hydrogens? Let me see now. Now I will explain on the PPT only this one. What are these alpha hydrogens and everything. Tomorrow shall I take class? Yes or no?
No, sir.
No, sir. No? Why?
No, sir.
Why?
Sir, daily classes, sir.
Sunday है sir.
Okay, we'll take on Monday. Monday? What time we'll take?
Yes, sir.
Same time, 9. We'll take at Monday our regular class. No, we'll take 10 to 11:30. 10 to 11:30 I will take on Monday.
Okay, sir.
We'll take 10:30 to 11:45, sir.
10:30 to 11:45. Do one thing, 10:15 we'll see. 10:15 to 11:40 like that. Okay. Actually, I'm taking class at 9 o'clock. 11th class I am taking. Daily I am taking 11th at 9 o'clock. After that class I am taking your class. Actually, I want to take your class at 9 o'clock, but you are having morning class, no? I think early morning. So that is the reason I'm taking the class at this time. Leave it these points, okay? Alpha hydrogens. What are alpha hydrogens? Per carbonyl compounds. Per carbonyl. This is the important thing, beta. If you know this one, remaining reactions will be easy for you. Now, what is the meaning of alpha hydrogen? So, for example, if you observe here, CH3, C double bond OH. Now, this is a functional group, right? Now, this carbon is called alpha. Now, how many alpha hydrogens are there, beta, here?
3.
How many alpha are there?
3.
3 alpha hydrogens are there. 3 alpha hydrogens are there. For example, if I write like this. Here, how many alpha hydrogens are there? This is a functional group, beta. How many alpha hydrogens are there? Yes?
6.
6. This is alpha carbon and this is also linked here with functional group here. Both are alpha carbons here. Therefore, how many? 6 alpha hydrogens are there. For example, if I write like this CH3, CH2, C double bond OH. How many alpha hydrogens are there here? This is a functional
2.
group. This is the alpha carbon having only 2 alpha hydrogens. For example, if I write like this CH3, CH2, C double bond O, CH2, CH3. How many alpha hydrogens it is having?
4.
4. This is alpha and this is 1. Okay. So 4 alpha hydrogens it is. For example, if I write like the CH3, CH3 and CH3, C double bond OH. How many alpha hydrogens are there here?
0.
0 alpha hydrogens are there. Remaining were not replying. Remaining one. Acetophenone will have how many alpha hydrogens beta? Acetophenone. How many alpha hydrogens are there for acetophenone? And how many alpha hydrogens are there for benzophenone? How many alpha hydrogens for acetophenone? And how many alpha hydrogens for benzophenone?
Acetophenone 6.
Acetophenone is having 6. How? This is called what?
5.
How many?
5.
How many alpha
3.
hydrogens? Acetophenone is having only 3 alpha hydrogens. Here we don't have any, because if you observe here what happened, the structure if you observe, now how many bonds are there at this carbon? 1, 2, 3, 4. Therefore here we don't have any hydrogens here. For this carbon there is no hydrogen. So it is having 3 alpha hydrogens. Now what is benzophenone? How many are having beta? For benzophenone?
0.
It is having again 2
0.
alpha hydrogens you are having. Now I think everyone understood what is alpha hydrogen.
0.
Everyone understood alpha hydrogens?
Yes, sir.
Right. Now we'll move to
Yes, sir.
the concept. The concept here. No. Reactions because of alpha hydrogen. When you have a alpha hydrogen, some type of reactions are taking place. Whenever if you have alpha hydrogen, some type of reactions are taking place. What are they? Let me see this one, isn't it? So what happens if you have alpha hydrogen? So for example, I'm taking a alpha hydrogen here. So this is an alpha hydrogen. C double bond O, isn't it? Now, if I take any base here, I'm taking a base. I'm taking a base, OH minus I'm taking. So this OH minus, I'm writing here OH minus. If I take any base, this base accept the proton from here. This base accept the proton. Okay, now this bond will be shifted over where here. Then this bond will be shifted over on oxygen. So because of this, what we are going to get here, CH2 double bond CO, isn't it, minus H you are going to. So this is leading towards some products actually. Because of this, what happened, it leads to some product here. So this, now what happened, this is releasing what type of thing beta? H plus. Releasing of a H plus is nothing but called releasing the proton. So releasing of proton is nothing but called acidity of alpha hydrogens of aldehydes and ketones. See, here it is releasing H plus. Which compound? This compound. So therefore, acidity of alpha, that means aldehydes or ketones which are having alpha hydrogens, they are having which character beta? Acidic character, because they lose this proton here. So because of this, what happened? They are undergoing some type of reactions here. What are they? The first one is called Aldol condensation reaction. The first reaction is called Aldol condensation reaction. Okay. First of all, we'll see Aldol reaction. Then we'll see what? Aldol condensation reaction. But if you observe like this, what happened is very difficult to remember these reactions. So if you follow the mechanism, what happened, it will be easy for you. So let me see the mechanism for this one. Now, first of all, I'll go for what? Aldol reaction here. This is Aldol reaction, right? Now, Aldol reactions are taken by whom? Only which are having alpha. First thing is that this Aldol condensation reaction takes place with carbonyl compound, both aldehydes and ketones, which are having what here? Alpha hydrogens. If you don't have alpha hydrogens, Aldol reaction do not take place. Undergoing what happened? Aldol reaction. Why? Because it is having alpha hydrogen. Understood here? This point is important before going to what? Aldol reaction. What is the condition here? Having alpha hydrogens. Okay, now it is having alpha hydrogen. How to make the product? I'm writing here. So again, I'm writing here CH3 C double bond O H. Just now taken something. What happened? OH minus here. Okay, when you take OH minus, what we got here? Again, I'm writing this one. CH2 hydrogen, so OH minus, right? This is taken by the hydrogen as H plus. This bond shifted over here, and this bond is shifted. You got like this CH2 double bond CO minus, and you got here, right? Now again, if it is shifted towards like this here, now what we get here? We are going to get this one. A nucleophile is generating. CH2 minus here, C double bond O. Correct? Understood this conversion better? Everyone understood this one?
Repeat the second step, sir.
This one. This one is very simple. No, the negative charge
Yes, sir.
over here. Now negative is converting into pi bond. And this pi bond shifted on this. This is a resonance structures only. No. The pi bond shifted over, we got a negative.
Yes.
Understood here. Now this is now act as a nucleophile. Actually, no need to remember this mechanism for only explaining how we get the product. In examination, nobody asks to write this type of mechanism. We need only product only. You have to write like this one. But writing directly is difficult. So for that also I make a shortcut for you. Just listen here. Now actually what happens out of this CS3 C double bond, second mole I am taking. I am taking first two moles are there no here. So first mole I have taken here. Now I am taking the second mole here. Now second mole is reacting with this one. Which one? CH2 minus C double bond O H. Now this is attacking where here? On this carbon. Now pi bond will be shifted over like this. Now what we are going to get because of this CS3 C O minus hydrogen, this one. Next, this attacking on the carbon, no. CH2 C double bond O H. Correct? This you got actually. However, again, this CH2 attacking on this carbon, and the pi bond shifted over here. So you got CH3 CO minus H. See, CH3 CO minus H. And attacking on this carbon, I'm writing like this. Now add H plus to this one. When you add H plus to this one, what we are going to get here? This product we are going to get. This is the product we are going to get. Add H plus to this one, you will get this product actually. After this is called Aldol reaction. Up to your Aldol reaction. Now what is Aldol condensation? When you remove a water molecule from this one, that is called Aldol condensation reaction. How to remove the water from this one? Just to do one thing actually. Put one hydrogen here. Put one hydrogen here. Put one hydrogen here, isn't it? Now what happened here? This bond will shift here and OH bond will be eliminated here. Now we are going to get this. This is called what? Crotonaldehyde. The name of this one is called crotonaldehyde. Crotonaldehyde, right? This is the mechanism. Is it difficult or easy? Mechanism. Is it difficult or something difficult only? I don't say what happened. It's very simple. Something difficult only. So in that case, what we'll do? How to remember the products here? So we'll do some what happened, some shortcuts for this one. Okay. Remembering this type of products, what happened? We'll do some shortcuts for this one. Only I complete the shortcut. After that, you can leave now. So remaining reactions, we'll see the cross order, everything day after tomorrow. So just I will make a shortcut for this one. How to remember? So see this one. Shortcut for this one. What will be the shortcut for this? Now, you have to make what happened? Two reactants like this. CH3, CH, okay, C double bond. Write down like this. For your understanding that. Otherwise, you keep this hydrogen here also, no problem. No problem. You can keep the hydrogen like this also. Right? Take another mole also. CH3, C double bond O, H like this. Take 2 moles like this. I've taken 2 moles of carbonyl compound which is having alpha hydrogen like this. Now what we have to do here? Now we have to do some modifications for this one. Now CS3 write down like a CH2 hydrogen. Okay, CS3 write down. First thing is what? Write down CS3 as CH2H. Right? Now remove this plus also. Right? Now what we have to do here? Now keep this H here. Where? At here. Keep this H at here. Okay. Otherwise, you do one thing. Instead of doing something, you do one thing. Keep this with respect to bond like this. Again, I am saying it. Bond like this. With bond. Now keep the pi bond here between these two. This is only we have to do. Remaining is what you will get everything. Very simple. This bond along with hydrogen, I am keeping on oxygen like this. This bond along with hydrogen, I am keeping on what actually here? Oxygen. And this pi bond I am keeping where? Between the two molecules. Between carbon and carbon I am keeping. Now what we get here? Very simple. H3. Okay. C. Now single bond. This pi bond we have shifted. No. Now O will convert into here what? OH. Now CH I am writing here. Now here between these two we get a bond like CH2 C double bond OH. Completed. With one step only, with 2 arrows only, I have completed the reaction. What happened actually? This bond with hydrogen I am keeping here like this. Otherwise, keep the hydrogen and oxygen and connect these two and remove the pi bond. Understood here? What I am saying? Keep the hydrogen over oxygen, remove the pi bond, connect these two here. You got the product here. Understood everyone?
Yes, sir.
No, I will take one more example. After this is Aldol reaction. Now, how to make Aldol condensation? This reaction is called Aldol reaction. Aldol reaction. Now, I am making Aldol condensation reaction. Aldol condensation reaction. If you don't follow the mechanism, follow the shortcut. Nobody asks in examination mechanism. You need only product only. Now, put one hydrogen, same CH2, write that like this. You can write CH2 like this, no problem. Now put this bond here and remove the pi, this OH bond here. Now what we get here? CH3, CH, okay, double bond, CH, C double bond OH. Crotonaldehyde, or numbering we can do 1, 2, 3, 4. This is called what? But 2-ene. 2-ene all. 2-ene all actually. Right? If I take one more example, I am taking here. One more example I am taking. CH3, C double bond O, CH3 I am taking here. Right? Next, take second molecule, same molecule. I have taken H2 here. CH3, C double bond O, CH3. Right? Now what we have to do? Again, you write this one in the manner like this. Better for understanding, you write like this. CH3, C double bond O, CH3. Keep the CH3 below like this. Next, CH3, how you writing? CH2, hydrogen, C double bond O, CH3. Correct? Next, what we have to do? Remove the pi bond. Remove the pi bond. Put this hydrogen where? Here. Right? And place this bond at here like this. So what we are going to get here? CH3, COH. And it is what here? CH3. You are going to get this one. CH2, C double bond O, CH3. This is called aldol. Now, how to get aldol reaction? Again, you write here hydrogen. This you break here, you will get the aldol condensation. Understood better? How to make the product?
Sir, while doing condensation, what if we remove the hydrogen of carbon which is on left side?
Alpha carbon only we are doing. alpha hydrogen only we are. See, this is the function group, alpha hydrogen. See, this is the function group, alpha hydrogen. Okay. In next class, I will explain crashed aldol, in which first, this is what same, no, first one, second what same molecules have. Now in the next class, what I will take, different molecules I will take. First one is different, second one different I will take. In that case, how we get the products we'll discuss. Here, if you see one, these two are what same only. Okay, these two are same. Practice these reactions, these two with that shortcut. Next class, we'll take aldol condensation reaction, crashed aldol reaction. This one, crashed aldol, different here. First one is different, second one different. In which we get four type of products actually. Four types of products actually, right? Understood better? So you have to practice up to aldol reaction. Tomorrow, I mean day after tomorrow, we'll complete the carbonyl compounds, the remaining topics also. Now, we'll see some exercise here. Is it possible for you? Order of reactivity. Order of reactivity. You can do this one. If you have any doubts, you can ask me in the next class, this 12.4. Now, can you say which type of reaction beta it is? It is there, N substituted. Yesterday we completed this one. All of you do this one. Amine, carbazide, 2,4 DNP, hydroxylamine will give oximes. Complete 12.5. I don't think you will get a doubt from this one. 12.5. No doubts from this one. Okay? Complete that one, 12.5. These are all IUPAC nomenclatures. IUPAC nomenclatures. GC. Write the products when the cyclohexane carbaldehyde. Cyclohexane carbaldehyde. This is the cyclohexane carbaldehyde. If this react with what? Phenyl magnesium bromide. So this is what preparation of alcohols by using Grignard reagent. Yesterday only we discussed this one. Tollen's reagent. CHO will convert into COO minus. Semi-carbazate, N substituted. Yesterday we discussed. Excess ethanol. This is also we have taken for protecting the carbon functional group. Ethanol we have taken 2 moles here. Zinc amalgam. Which reaction it is? Clemmensen reaction. Clemmensen reaction it is. So all are what? Very simple for you. This part we'll see in the next class, 12.7, we'll see the next class, right? So this is only the homework you have to complete. So by Monday, I told you, neighbor reactions, what happened? Aldol reaction also include that one. Today you have to post this one. Today by evening 5 o'clock, whatever the exercise you are completed, send in the class, Google Classroom, okay? Whatever the exercise are given, complete that one, send into the Google Classroom today itself.
सर टाइम थोड़ा इंक्रीज करो सर.
थोड़ा टाइम एक क्लास लेने के लिए और आधा घंटा ले लो. ओके, नो प्रॉब्लम, आई विल टेक क्लास.
ड्यू डेट सर
सर सबमिट करने का सर.
सबमिट करने के लिए, क्लास लेने के लिए नहीं है. ठीक है, मंडे तक सबमिट करो, ठीक है ना?
यस सर.
ठीक है सर, बहुत थैंक यू.
मैं थोड़ा अटेंडेंस लेता हूँ. All of you. Amruta, Anupama, Dhruv, Bhuvaneshwari, Deva, Harivom, Manjusha, Kiran, Nehayam is absent. Nidhi, Nikita T, Nishant, Parth absent, Devashish, Pragnya, Pranali, Rani yesterday absent है ना बेटा? Rani.
No sir, I was present sir.
वो झूठ मत बोलो, रिकॉर्डिंग है मेरे पास, मैं रिकॉर्ड भी किया उसको. इसमें सब कुछ दिखाते हैं, दिखाओ मेरे को, कल का वीडियो देखो एक बार. You are absent. You are saying what happened present. झूठ मत बोलो. रिकॉर्डिंग, ये रिकॉर्डिंग हो रहे हैं. कल भी मैंने रिकॉर्डिंग में लिया प्रेजेंट सेंट. ऑल अटेंडेंस हैव टेकन इन द रिकॉर्डिंग मोड ओनली. You are saying what happened present. How it is possible? झूठ मत बोलो. Next. Rohini is also absent yesterday. Rohini also absent. Radhika absent today. Samiksha. Samrin yesterday absent. है ना? Samrin. सो रहे हैं Samrin?
Present, sir.
Yesterday absent है ना आपका?
No, sir, I was present.
You are absent yesterday. Samruddhi. Shivani.
Yes, sir.
Shreya Paushe. Shreya. Sneha. Swapnali. Tejas yesterday absent है ना बेटा तुम?
Yes, sir.
वैष्णवी बेलगांवकर. वैष्णवी के. वैष्णवी SB yesterday absent. वैष्णवी SB.
Yes, sir.
Vanita. Venkatesh. Varsha also yesterday absent.
Yes, sir.
Vinayak. Okay, you can leave now.